Hi everyone, it's Mrs. Griffin with the Unit 2 Lesson 3 video about midpoint formula, where you're going to learn how to find the midpoint or endpoint of a segment. So the opening exercise is review from Algebra 1. I'd like you to give it a shot and see if you remember how. For solving it, we would subtract our 5x from both sides because we would want to be able to graph it. And the format it is in right now, it can't be graphed. So we'll put y equals mx plus b form. Then we're going to divide by -4. On both sides. And don't forget that when you divide or multiply by a negative when solving an inequality, it flips the inequality symbol around. So we end up with a less than or equal to instead. And then we're going to divide each part by 4. So -5x will divide by 4 and make a positive 5/4 x. And then we will also do +4 divided by 4 and get a -1. And then we could graph that like a line. It would be a y-intercept of -1. And it would go up 2, 3, 4, 5, right 2, 3, 4. And I could do a couple of those. 1, 2, 3, 5, 1, 2, 3, 4. And then also down 5 and back 4. And I would get a line. But when I graph it, I also make sure to consider whether it's a solid or dotted line. We do a solid line if we have equals bars underneath and dotted if we don't. This particular one has the equals bar, so it's going to be a solid line. We're going to put arrows on the end. And then we also have to remember with inequalities that because they're inequalities, we have shading because we have many points that meet our solution. So you pick any point you'd like to test. For example, I'll do this point here, which is 1, 4. And we see if it's true by substituting in. I usually use the original. So if I'm checking the point 1, 4, I'm plugging in a 1 for x and a 4 for y, and seeing if that is true, if that is greater than or equal to a +4. And it is not. -11 is not greater than or equal to 4. So this is a false inequality, and therefore I shade away from the point 1, 4. I shade on the other side where it would be true points. Any point on this side would make a true. Okay. Another shortcut to graphing the shading is to look at the symbol once you've got it in y equals format. If it says less than and equal to or just less than, we shade down. And if it's greater than or equal to or just greater than, then we shade up based on where the y-intercept is. So our y-intercept was here. That's why we shaded down, because it said less than. Okay, so now that we've reviewed that for our future lessons, let's go into the midpoint. Midpoint formula is used to calculate the coordinates of a point equidistant between 2 points. The midpoint formula, it's a capital M, or a lot of people will write MP for midpoint, looks like a coordinate point where we have x's and y's. It's going to have parentheses and a comma. The middle between two objects is what happens when you average them. So you add them up and divide by 2 because there's 2 of them. We're going to do that with our x's and our y's from a point. So if we were to look at number 1a here, to find the midpoint, all we have to do is average the x values, which were 2 and 7, and the y values, which were 11 and 6. 2 plus 7 is 9, divided by 2 is 4.5. 11 plus 6 is 17, divided by 2 is 8.5, and that would be the midpoint. We could also do this graphically. So I've graphed those same points here on a random axis. If I wanted to find the midpoint, I'd be figuring out how far away they are vertically and horizontally and cutting that distance in half. So I'd have to go down 2, 3, 4, 5 and cut that in half to be down 2.5. And the horizontal distance between them is 1, 2, 3, 4, 5 as well. So I would cut that distance in half and be 2.5 away from each one. So I could go down 2.5 and over 2.5 to get my midpoint that way. And you can see that is exactly at 4.5 2, 3, 4, 5, 6, 7, 8.5. I personally find it longer to graph everything, but if you need to, you can use a graph. All right, so for B, we're going to do the formula. So we're going to average our x's and average our y's. And we will see that 5 plus negative 1 is 4, divided by 2 is 2. Negative 6 plus 9 is 3, divided by 2 is 1.5. Or you can always write it as a fraction, 3/2 as well. And you could have done that graphically if you preferred. These ones here where we have variables, you really can't graph that. So we have to stick with our formula where we average our x values and average our y values. And so 5c plus 1c is 6c, and then divide that by 2 and you get 3c. 2d plus 8d is 10d, divided by 2 would be 5d. Okay, going on. Number 2, given the coordinates a and b, what are the coordinates of the midpoint of AB? So again, just more calculating, see what you get. Hopefully you got negative 4, 6 like I did. Try number 3. I got 3/2 1 or 1.51 is also acceptable. Averaging is adding and then dividing by 2. Now, number 4 is a midpoint question in disguise. It's talking about a circle, and it's saying that A and B are endpoints of a diameter. A diameter is a segment that goes through the middle of a circle. And so if that's the case, then the middle of the circle, called the center, is the midpoint. So when they're asking us if the coordinates of A are 3, 4, and the coordinates of B are 7, 8, to find the coordinates of P, which is the center of the circle, they're just asking us to apply the midpoint formula. And so like all the others, we can average the x's and average the y's, and very quickly get 5, 6. Okay, number 5 is another one in disguise because we're talking about a parallelogram, ABCD. Remember that when you are labeling a parallelogram, doesn't matter what corner you start at, but you must circle around connecting the corners. It says the coordinates of A are 6, 7, and the coordinates of C are 12, 3. It's asking for the point of intersection of the diagonals. So if you can remember, the diagonals bisect each other. And if that's the case, then the place where they meet, that point of intersection, is the midpoint. So we're really just finding the midpoint between A and C. So again, we're applying our midpoint formula. We're averaging our x's, we're averaging our y's, and getting 9, 5. All right, now 6 is a little bit different because 6 is talking about a segment where it has a midpoint given to you already, and then it tells you one of the endpoints and would like you to find the other. So I'm going to show you on a graph first. If I look at number 6, I've got those points graphed here. A is at negative 1, negative 2, and the midpoint is at 3, 1. We need to find B. So B has to be the same distance away from the midpoint as A is. And if I count it, I went up to 3 units, right 2, 3, 4 units. And if I repeat that, my distance will be exactly the same. 1, 2, 3, 1, 2, 3, 4. And this will be my point B. 1, 2, 3, 4, 5, 6, 7, 4. If I want to apply that same concept without graphing it, I can create a little image and almost do like an XY table. Okay, so my point A had the coordinates of 3, 1. The midpoint was 3, 1. The coordinates of A were negative 1, negative 2. And I could just calculate the change and repeat it to get point B. So to get from negative 1 to 3, I had to add 4. If I add 4 again, I will get 7. And for the y values, I have to add 3, and then adding 3 again gets me 4. Just remember to write the point out when you're done if you do it that way. You can use the formula too. It creates little proportions if you do that. You are plugging in to all of this and creating 2 different equations if you do it that way though. And this is not a required way, so up to you. If you do it this way, you are treating A as x1 and y1 and plugging them in accordingly. And then we don't know the other x value or y value, so we leave them as the variables. And then what we do is we say we're going to make one equation to set the x's equal to the x's, and a second equation to set the y's equal to the y's. And we have to solve them both. So for the x's, the 3 would be equal to -1 plus x over 2. Multiply by 2 on both sides. Add the 1 over, and you'll get x is 7. And then for the y's, the 1 equals -2 plus y over 2. Multiply by 2 on both sides. Add the 2 over, and you get y value is 4, and then you can get that same answer anyway. I prefer the picture way here myself. So for the rest of them, that's what I'm going to do. So we have M as the midpoint of CD. I'm going to sketch that out. C is 610, and M is 7, -2. So if I just calculate the change from here to here, I have to add 1. If I add 1 again, this will be 8. From here to here, 10 to -2, I'm subtracting 12. And if I subtract 12 again, I'll get -14. And so D is at 8, -14. Number 8. A is one endpoint of the diameter of a circle. So again, we're dealing with a midpoint question in disguise. And the center of the circle O is at -3, 7. What is the other endpoint of diameter AB? So similarly, I can just figure out the change from 1, 4 to -3, 7, and then repeat it to get B. So to get from 1 to -3, I have to subtract 4. Subtracting 4 again gets me -7. And to get from 4 to 7, I have to add 3. So adding 3 again will get me 10. And then I'll see that B is at -7, 10. Okay. Number 9, we have a quadrilateral. Here are the vertices. Remember, when you label a quadrilateral, however it is, you go around the shape. I have no idea what kind of quadrilateral. I'm just drawing that. It says to find the coordinates of the midpoint of diagonal AC. So for this one, we are comparing A and C only, and we're going to use the midpoint formula to find the midpoint. So we're going to average our x's. We're going to average our y's, and we will get 0, 5. Then if we do for BD, we are looking only at B and D. We're going to average our x's. We're going to average our y's, and we will get also 0, 5. Based on the answers to part A and B, what type of quadrilateral is A, B, C, D, and Y? If the diagonals have the same midpoint, they must bisect each other, because that's what's going on if we bisect. Since the diagonals are bisecting each other, I'm going to use EO for an abbreviation for each other. Then ABCD is a parallelogram. I'm going to use the abbreviation for parallelogram, which is the letter P inside a little parallelogram shape. It's the only one that gets that abbreviation. So that's the least specific shape that has diagonals that bisect each other. Of course, it could be a rectangle, a rhombus, or a square. Those are all types of parallelograms, but all we definitely know for sure is it's a parallelogram. All right, I will see you in class.